Welcome dear viewers to the present video on tablet pellet coating types and their applications. So as a pharma professional, we should always have understanding about the coating process, whether it is tablet coating or it is pellet coating or beads coating. And this understanding is always very important for the professionals working in various departments like R&D, QC, QA, production, regulatory affairs and other related cross-functional teams. Let's start with the video for the coating types. Mainly the coating for tablet and pellets are divided into two types based on to the function of coat and based on to the solvent system utilized for performing the coating. Non-functional coating and functional coating, these are the two types based on to the function. And function meaning the effect of coating onto the drug release and dissolution. So non-functional coating is the coating which doesn't affect the dissolution of drug or drug release from the formulation, whether it is tablet or pellet or mini tablet. Non-functional coating has no impact onto the dissolution. That means generally non-functional coating will give you the immediate release type of formulation or it will not impact the dissolution. Then functional coating. Functional coating is done to perform some alteration or modification in the release rate or dissolution of the formulation. Non-functional tablet coating are mainly three types like film coating, sugar coating, and coating performed for increasing the glossiness or shining onto the tablet, and also sometimes film coating utilizes the use of flavor, and flavor is used into the coating. Flavor coatings are performed onto the nutraceutical formulations and some pediatric type of formulations. Functional tablet coating involves the coating like enteric coating, which is also known as delayed release coating or gastro-registered coating. Then ER coating, that is extended release coating. Then semi-permeable coating. Drug layering, that means sometimes the drug is also used in the coating process and drug solution or suspension is sprayed onto the tablets or pellets. So that is the functional type of coating. Then barrier coating or seal coating. I have included seal coating in the functional tablet coating part. Then coming to the coating type based onto the solvent system. It is aqueous coating, non-aqueous coating and hydroalcoholic coating. So these terminologies are used generally like aqueous film coating, aqueous non-aqueous film coating, and these are based onto the core of the tablet API or the sensitivity of the API towards the coating parameters like temperature. Then hygroscopic materials are generally coated with the non-aqueous type of coatings. So I will make some videos onto the coating process and coating formula. So stay tuned with this channel. For present video, we are going to see the applications and why these coatings are done. So aqueous coating utilizes the water as solvent. Non-aqueous coating utilizes the solvents like alcohol, acetone, isopropyl alcohol, ethanol sometimes, then MDC. And hydroalcoholic coating utilizes the water and organic solvent. So it may be IPA water or in acetone water or ethyl alcohol and water. First is film coating. So it is the non-functional type of coating and it doesn't alter the drug dissolution. For some of the critical formulations, film coating may have little bit impact onto the disintegration and that's why it will affect the initial dissolution time points only. Film coating is a thin type of coating with the weight gain of around 1.5 to 4% onto the tablet core, and it may be containing the color, talc, or titanium dioxide. and it may be opaque or colored. Sometimes for some of the bilayer formulations, clear coating is also applied. It dissolves rapidly and generally doesn't alter the dissolution of the drug. So film coating, as I have mentioned, it is non-functional coating, and film coating may be performed with aqueous and non-aqueous solvent system. Mainly the polymers utilized in the film coating are HPMC, polyvinyl alcohol, and some other can be used. So the reason for performing coating uh, may be very depending on to the formulation and the product requirement. Mainly film coating is done to improve the appearance, to have a good look for the tablet and mini tablet or pellets. It improves swallowing of the tablets because it makes uh, a slippery surface onto the tablet whenever it is coming into contact with the water, because it is coated with the polymers. Then it masks the core tablet color and odor. Sometimes the core may be having mottling effect or maybe some spots because of the manufacturing or API nature or excipient nature. So those can be masked with the coating. It improves patient acceptance for the formulation. It provides protection from light, moisture, and it oxygen, and it improves the shelf life of the formulation. It is also done to differentiate the product. So some products have some different color codes and coatings. Then it is also utilized to have identification or differentiation of the different strength of the same product. So these are some of the applications for film coating. Then coming to the sugar coating, as the name indicates, it utilizes the sugar type of material for coating, and it is a multiple stage coating. So different stages are there. Sugar coating is a little bit critical compared to film coating. Sugar coating also dissolves rapidly and does not alter the drug dissolution. It is also done sometimes to protect the API from environment, and it improves the patient acceptance. It masks the taste. It acts as a barrier to external environment. Here, the weight gain in sugar coating is higher, and it depends on to the formulation. You can go up from 30 to 100% as well. So weight gain is more. That may be the disadvantage that due to the higher weight coating, your core shape may get changed after coating, and that doesn't happen with the uh, film coating. So logo cannot be given onto the core whenever sugar coating is required because of the weight gain. That logo will go off. It also provides benefits like film coating, and it can improve the patient compliance. Then coming to the coating for glossiness or shining and flavor coating. So as the name indicates, it makes the tablet more shining in nature and appearance. Uh, This film coating is done to improve appearance of the tablet. It is very similar to the film coating, but this coating is done for some of the formulations like nutraceuticals and some pediatric type of formulations. Some vitamin formulations or calcium supplements. These gloss and flavor coatings are done. It provides percent finish, glossy look, and its weight gain is like 0.5 to 1% around for the glossiness. And for film coating with flavor, it may be from 1.5 to 4% maximum, like film coating. Flavor is generally used in the film coating for nutraceuticals and vitamin tablets to improve the patient compliance, and it gives you the all the benefits of film coating. Now coming to the functional coating. So it is enteric coating. First example is enteric coating. It is also known as delayed release coating, and also it is also called as gastro-resistant coating. So it involves the use of enteric polymers to protect the acid level drugs from acid degradation. So whenever the drug is sensitive to acid, the enteric coating may prevent the release of API into the stomach where the environment is acidic, and it is it releases the drug into the intestine where the environment is basic. By enteric coating, dissolution is prevented in acidic environment of the stomach and dissolution takes place in the basic environment of intestine. It is also called as delayed release coating, gastro-resistant coating, or sometimes delayed action coating. Then enteric coating is also performed to target the drug release at specific site of the intestine or colon. Enteric coating can be applied to the mini tablets, pellets, and tablets. Some formulations are also available in the granules form. And for enteric coating, mainly the uh, polymers utilized are acidic in nature, and these polymers doesn't dissolve in the acidic environment, but these polymers dissolves and swells in the basic pH environment, and that is the utilization of these polymers property for enteric coating. Generally, enteric coatings are non aqueous and done with the solvents like acetone, ethanol, and other solvents, depending on to the formulation and enteric polymer used. HPMC acetate succinate is the polymer, HPMC phthalate is the polymer, and some polymers are there in the methacrylic range like methacrylic acid, methyl methacrylate copolymers. So depending on to the release pH, the polymer is selected and its coating weight gain is decided. Then ER coating. So extended release coating, you can say it as modified release coating or sustained release coating, prolonged release coating or controlled release coating. So different terminologies are there, and these coatings are done to specifically get the dissolution profile for the modified release type of formulations. And these coatings can be applied to the tablets, pellets, and granules. But mainly tablets and pellets are the formulations available with this extended release coating. So the polymers are insoluble in nature mainly. pH independent or dependent polymers can be utilized. The polymers are like ethyl cellulose, cellulose acetate, and polyvinyl acetate. Mainly ER coating involves the use of solvents for coating process. As these polymers are insoluble in water, so solvents are utilized. Then semi-permeable membrane coating or osmotic type of coating. So this coating is used for the osmotic type of formulations uh, for getting the semi-permeable membrane onto the cover tablets. Cellulose acetate is the prime polymer and it is used along with the PEG as cover former and some other excipients. So for making the semi-permeable membrane, the cellulose acetate is the desired polymer. Osmotic tablet is a type of modified release tablet formulation. Drug layering. So now, as we have seen, there are many types of coating, but in the drug layering or drug coating, the API is kept into the coating solution or suspension, and that drug containing solution or suspension or dispersion is applied onto the tablets or maybe applied onto the pellets. So that is called as drug coating or drug layering. API is taken into the coating part to get the specific release in combination formulations. Like biphasic release tablets including immediate release and extended release. So immediate release part will be in the coating part and the core will be extended release. Drug coating is also done to separate the incompatible drugs. So if combination formulation is there and if the two drugs are to be used into the same formulation for combination, then a drug can be kept into the coating part to separate the two incompatible drugs. Then drug layering is also done mainly in the pellet type of formulation because in the pellet formulations for low dose type of formulation, drug is kept in uh, drug layer to have the specific release profile and pharmacokinetics. So based on to the product requirement and based on to the reference product profile, uh, if the product is generic product, that time drug layering is done. Sometimes the pellets are made with the drug and some functional and non-functional coatings are applied onto the core drug containing pellets. This formulation is like film coating, but the excipients like binder, excipients like polymers can be changed or can be optimized to have specific release of the drug. So this drug layering or drug coating I have taken into the into the functional type of coating. This functional coating can be done onto the tablets, pellets, mini tablets. After drug coat, film coat is generally applied to protect the coated drug. Then drug layering, then barrier coating, or it is also called as seal coating. This is done mainly where multiple coatings are there, and this barrier coating or seal coating is done to separate the two coatings as a barrier coat in multiple coated formulations, whether it is tablet or pellets. Seal coat provides the smooth surface for functional coating. So the barrier coating or seal coating is done to have smooth finish for the further coating process. Seal coat is also provided to make the pellets less friable for further process. Seal coat is also like the film coat. It is a non-functional coat, but it affects the release in MR type of formulations. So it is included in the functional type of coat. Mainly the delayed release formulations involves the seal coat or barrier coat. Also, many of the pellet formulations involve the use of seal coat. So examples are like pellet cover is coated with seal coat, then drug coating is done, then again seal coating is done, and then functional coating or enteric coating is done. Then a tablet cover. Onto the tablet cover, apply the seal coat and then can apply the enteric coat. Then seal coat can also have the property of separating the two layers. In enteric coating formulation, the enteric polymers are acidic in nature, so seal coat is given to protect the acid level drug from acidic properties of enteric polymer. Many of the times, two coatings are separated for having the release profile and also for improving the stability of the formulation. So these are the types of film coating onto the pellets and tablets. Multiple layering can be done to have CR tablets or CR pellets, pulsatile drug delivery system involving the modified release or extended release type of drug design, DR, that is delayed release, then modified release design, or IR with ER design. So these are the main tablet and pellet coating types and their applications. I hope you might have got good information from this video, and I request you to do like, share and subscribe to this channel. Thank you for watching the video.